This is the lesson for 11-7 day one. So what you're doing today is you are looking at, over the next couple days, you're going to look at three different kinds of what they call transformations. You're going to look at a translation. This is what we're doing today, where a picture slides from one place to another place. It might just slide up. It might just slide down. It might just slide to the left, just slide to the right, or a combination like this one is going up and to the right. But all you're doing is sliding a picture from one place to another place. Tomorrow's lesson, we'll be looking at reflections and dilations, and we'll talk more about those tomorrow. A reflection is a flipped opposite mirror image, and a dilation makes the graph bigger or smaller. So again, what you're looking at today are translations. All that we are doing is sliding the picture from one place to another place. So there's a couple different kinds of translations. Again, you could just slide it up, just slide it down, just slide it to the left, just slide it to the right, or a combination of them. So let's take a look at the ones that go up and down first, your vertical translations. Now, what makes it go up and down? What makes it go up and down is adding or subtracting a number to the entire function, all right? So let's say that this f of x equals x squared. That's our original picture, all right? Our original picture is this blue graph. And if we go and we add 3 to the entire function and we graph that again, what is going to happen to the graph is that it is going to slide up. So anytime that you add a number to the entire function, you are going to slide it up that number of places. Anytime that you subtract a number from the entire function, it's going to go down. So take a look at this next one. We have our original one here. Now, our original one, again, is in the blue. And then if we take that original one and we subtract 2 from the entire function, it is going to move that entire function down 2. Now, when I say up and when I say down, what I am specifically looking at is on the y-axis. All right, on that y-axis, this one is going up 1, 2, 3. This one is going down 1, 2. So we're taking that and adding it. We're going up, subtracting it, going down. That is from the entire function. Now, what makes it go left and right? So a horizontal move, all right, either going left or right. All that you are doing to make it go left or right is adding or subtracting a number to the x value, all right? Not to the entire thing, just to the x value. So again, we have our original one here. Our original one is in the blue. If we just add 3 to the x value, what that's going to do is that's going to make it go 3 places to the left on the x-axis. So notice that our original one was right here at 0, 0. We're going 1, 2, 3 places to the left. Now, be very careful. Where people mess this up every single year is you would think adding 3 to the x would move it to the right, but it doesn't. Adding 3 just to the x moves it to the left, all right? It happens because remember how before we said that it has to equal 0? It has to do with that equaling 0, all right? So that's why it moves over to the left. So just know that if you add it, it goes over to, if you add a number just to the x, it goes to the left. If we subtract a number just from the x, it's going to go to the right. So here we are subtracting 2. Our original one was the blue. We're subtracting 2 just from our x value. So it's sliding from 0, 0 over to 2, 0. we're going over to the right 2 places. So adding it to the entire thing by putting it at the end, our plus or minus sign, that moves it up or down, adding going up, subtracting going down. If it's just to the x, if we add it, it goes to the left. If we subtract it, it goes to the right. Now, you could actually go through and graph these things if you wanted to. We could type in x squared as our y1, and we could type in parentheses x plus 3, close your parentheses, squared as our y2. You could graph them both on the same graph and see how they move. All right. The safest way, if you don't know for sure, or when it comes to the Regents exam and you want to check your work, you could always graph these to figure it out. Now, the ones that move a combination of things, all right, the ones that move a combination. Now, take a look at what this graph is doing. Our original one is the blue. So we originally start off at 0, 0 here with our vertex. Notice that we are going 1, 2, 3 to the left, and we're going down 1 to get to here. So 3 to the left and down 1. Well, what is 3 to the left and down 1 going to look like? Here's our original one. If we wanted to go 3 to the left and down 1, we would have to add 3 just to the x value and subtract 1 from the whole entire thing. You could double check your answers by typing in your original one and graphing it, typing in the new one and graphing it, and look and see how it actually moved. All right. You could do your min and your min. All right. You could do your min and your min. Second calc min. So again, remember, if you're adding to the whole entire equation, you're going up. If you're subtracting from the whole entire equation, you're going down. If you are adding just to the x, you're going to the left. If you're subtracting just from the x, you're going to the right. This is a slide in your notes that you're going to want to go back to, or you might want to write it down, or maybe take a picture with your phone. All right. This is something that you need to keep in front of you so that you can keep straight what is exactly happening here. All right. What's exactly happening here. So adding to the whole entire thing, it goes up. Subtracting to the whole entire thing, it goes down. Adding just to the x, it goes to the left. Subtracting just from the x, it goes right. Remember, tomorrow we're going to add more rules with reflections and dilation. So you need to know these. So let's take a look at some of these. So let's just assume that your original equation is just x squared. So we need to describe exactly what's going on. So when I take a look at A, all right, when I take a look at A, I can see that I'm adding 7 just to the x value, and I'm subtracting 4 from the whole entire thing. So if you're adding 7 just to the x, that means we're going left 7. And if we're subtracting 4 from the whole thing, that means we are going down 4. Take a look at B. In B, notice that we are adding 2 just to the x value. If we're adding 2 just to the x value, our graph is going to move left 2. Are we going up or down at all? No, because there's no plus or minus after that squared, like how the -4 was in the previous question. There's no plus or minus there, so all we're doing is going left 2. Take a look at C. We have a -3 just to the x, and we have a +1 to the whole thing. If we have a -3 just to the x, that means we're going right 3. +1 to the whole thing, that means we're going up 1. Take a look at D. In D, we have a -5 just to the x. That means that would be right 5. This is another combination one. We have a +1 just to the x, and we have a +4. That +1 just to the x makes it go left 1. And the +4 means that we're going up 4. Now be careful, all right? Sometimes this is the kind of question in F that tricks people. Notice that we're just subtracting 2 from the whole thing. When it's just the X, it would be inside parentheses like this. Notice that we're not doing that just to the X. This -2 is to the whole thing. So this would be a down 2. Go ahead and try these 6 on your own, please. I'm going to give you about 1 minute. You could just write them down or you could just think about them. Go ahead and do this one, please. Go ahead and try all 6. So let's take a look at these. You're subtracting 1 just from the X and you're adding 3 to the whole entire thing. So subtracting 1 just from the X is going right 1. Adding 3 to the whole thing makes it go up 3. Subtracting 5 just from the X makes it go right 5. Adding 2 just to the X makes it go left 2. Adding 4 to the whole thing makes it go up 4. Subtracting 4 just from the X makes it go right 4. Subtracting 2 from the whole thing makes it go down 2. Adding 3 just to the X makes it go left 3. Subtracting 4 from the whole thing makes it go down 4. Now be careful on this one. This is the type of question that screws people up. Adding 2 to the whole thing. That means we're going up 2. Notice that we didn't take it from the X. This is adding 2 to the whole thing. Now, it does get a little bit more challenging. Those questions and the previous questions were when the original equation was just x squared. Well, what happens if it isn't just x squared? So in these ones, your original equation is this time for m. Your original one isn't just x squared, it's x squared plus 4. Well, what's the difference between the f of x and the g of x? How do you get from here to here? Well, notice that our plus 4 is staying the same. So it's not going up or down at all because that plus 4 stays the same. The only difference between the f of x and the g of x is what's happening to this x. What's happening to this x is that we are adding 1 to it. Since we're adding 1 to it, that means we would be going left 1. Take a look at n. This is our original, x plus 2 squared. How do you get from x plus 2 squared to x plus 2 squared minus 1? Well, the only difference is the minus 1 at the end. That minus 1 at the end means that you're going down 1. Take a look at O. O, this is our original one, x minus 5 squared. Notice that we have x minus 5 squared still, but then we're adding 6 to the end. If we're adding 6 to the end, we'd be going up 6. And then in P, we have x squared minus 9. That minus 9 stays the same. The only thing that's different is this minus 1 just to the x. If it's just to the x, it is right 1. Again, when it comes to your test next week, I would strongly recommend that you graph them and look and make sure. It's very easy, especially when we add in tomorrow's rules. It's very easy to screw up all these rules. It might seem super easy today, but it might be a little bit more difficult when we add in the other things because you're going to have a combination of things between like translations, reflections, and rotations, or not rotations, dilations. So you're going to have to see what happens. So again, if you're adding or subtracting to the whole thing, you're going to go up or down. If you're adding or subtracting just to the x, that's when you're going to go left or right.